So next, what we are going to implement directed graph. How is this different from undirected graph? The graphs just have an edge. So code-wise, how will this differ from implementation for undirected graph? Earlier in undirected graph, what we are doing is adding uh, 1 to adjacency list of 0, as well as we were adding 0 to adjacency list of 1, since how we were treating them as two edges. Now in directed graph we have a direction associated with each of the vertex. So instead of adding both the vertex to each other's adjacency list, we just have to do it once. So code wise, let's see how this will change. So pretty much the code will be similar. So I'll just copy and let's create a new directed graph class, and I'll just paste it and okay. So let me change all the undirected graph to directed graph. Okay. Now the only thing that I'm seeing is going to change is this line. This line won't be needed since it is a directed graph, and we can say that we can change the nomenclature to this being from, and the other vertex being the two. This will be the to vertex, this will be the from vertex. Okay. And if we go up, the adjacency list will still be obtained from the vertex, and this is the only part that is going to change. Now let's check what happens for let's test it out. So the graph has an edge from 0 to 1, and the edge is from 1 to 2. The third edge is from 0 to 2. So when you try to fetch something from get everything that is adjacent to 2, since this is a directed graph, there is nothing adjacent to 2. So ideally we should get empty output basically. So let me run and check. Yeah, we are not getting any output. Now if I change this to 0, we should be getting 1 and 2 both in the output. So let me run this again, and let's see if we are getting, yeah, we are getting the output as 1 and 2. So that works out. Next I'm going to explain how to implement edge weighted graph.